So I called this review of graphing parabolas. I think you all did this last year, but with the job situation, all the action and things, I'm not sure that every one of your teachers may have covered it. So hopefully it's review. I said, remember, a quadratic function is a function that looks like this. Y equals ax squared plus bx plus c. This relates to the last lesson, Sterling, where I said, what makes a quadratic a quadratic? What makes a quadratic a quadratic? A squared. And if you have it all FOILed out so that all the terms are gathered, and instead of if an equation, you're graphing it, so instead of equals 0, it's now y equals, it's a quadratic function. Oh, I had to add some conditions. I had to say that a, b, and c have to be real numbers, nothing funky or strange. And I said a can't be 0. What if a was 0? What would happen to the x squared term if a was 0? It would vanish, and now it's not a quadratic. You're not going to get a parabola. It's going to be a straight line. So I do have to be fussy, and I just, as a nerd, mentioned that. We call this version here general form. It's the most useful if you're plugging in x's to find y's, so it's the most useful for substitution. It's the most useful if you're solving if it's equal to 0. It's the most useless if you're graphing. It's terrible for graphing. In fact, we can also write a quadratic equation in standard form. Now, I was taught that this was called standard form, and it sounds like over the last couple of years, they're changing this to vertex form. So I'll add that phrase there. I need to do some research and find out which one is actually correct. And what is standard form? It was a vertex form or standard form. It was a parabola that looked like this. Y equals a bracket x minus p all squared plus q. Where each of those meant something. Oh, and again, where a can't be 0, because if you put a 0 in front of that bracket, your x squared term will vanish. In fact, all your x's will vanish. How many of you saw that last year? Okay, we'll review what it means. You may have seen it with different letters. In the US, instead of P and Q, they use H and K. Well, you know what? It's two things that go there. I'll stick with the P and the Q because that seems to be what Europe and Canada do. This graph is a parabola. How do I know? Just by glancing at it, that it's a graph of a parabola. The same way that I know an equation is a quadratic, how do I know? It's got a squared. This is your first real curve. In Math 10, you learn slope-intercept form. You learn how to graph straight lines, and they're kind of cool, but they're boring. In Math 11, you learn the rules for graphing this particular curve. And it turns out with a bit of adjustment, we can generalize these, and we will later on this year, to apply to any graph, any curve, any function, which is great, Mark. It means you no longer really memorize how to graph any specific thing. You memorize a few general rules, and you say, if you show me the basic graph, I can do whatever you want to it. It's a nice shortcut. So this graph is a parabola. What's its vertex? Ooh. Ah, nice. Its vertex is P, comma, Q. The negative in front of the P, Brianna, was to remind you that the number in the brackets was backwards. If you're looking for a dumb way to remember it, the number in the brackets was backwards. The number in the brackets was... So if there was a +3, that actually meant the vertex of -3 for the x. And then the Q is your y. So I wrote here, graph the function with the equation y equals x squared by completing the table of values. Okay, so here's your x values. Square them to get your y values. What's -3 squared? In your heads, please. 9? Or is that a German student saying no? No? 9? 9? No? Real? Okay. Ein bisschen. -2 squared. -1 squared. 0 squared. And then 1, and then 4, and then 9. If I graph this, this graph goes through 0, 0, 1, 1, and negative 1, 1, 2, 4, and negative 2, 4, 3, 9, and negative 3, 9. Nice yawn there. And it's a smooth curve. It's sort of horseshoe shaped, but not quite. This was the basic shape of a parabola. We put arrows on the end to remind us that it does keep going. It keeps going out. It keeps going up. And this brings us to what, when I teach this, and I didn't teach you this last year, I call my mantra. A mantra is a chant that you say over and over to help you relax. Well, the mantra for the parabola is 112439. Look up. It's 112439. Say it with me. 112439. Again, 112439. I kid you not, if you know that, you can graph any parabola on the planet in your head. It's called learning the key points. I call it the mantra. It's the key point method. When I introduce other graphs to you, all we're going to do is we're going to memorize their key points, their mantra, and then rather than do any fancy math, whatever equation they can give me, we can graph it by just distorting those key points. 112439. Do you see where it comes from? It comes from 1 squared is 1, 2 squared is 4, 3 squared is 9. So you almost don't have to memorize it, Laura, if you know that every parabola is based on y equals x squared. And I've tried to do a big song and dance the last couple lessons about what makes a quadratic a squared. Some terminology. The line that splits the parabola in half is called the axis of symmetry. You can abbreviate it A of S. It's a vertical line. What's the equation of this axis of symmetry? That's a point. What's the equation? If it's going to be an equation, it's going to have an equal sign. Otherwise, it's not an equation. Now we're going to brush some cobwebs off. Vertical lines that are parallel to the y-axis are x equals. Horizontal lines that are parallel to the x-axis are y equals, and we'll talk about why that is as the lesson progresses. But this vertical line has an equation, x equals what? What's the x coordinate everywhere on that line? That's the equation of this line's axis of symmetry. I don't care what height it is, but no matter where I am, do you know how far left I've gone? 0 left, right. The vertex is where the axis of symmetry intersects the parabola. That's a fancy way for saying, Kyle, it's the top or the bottom, depending on which way the parabola opens. Fancy word. It's the maximum or the minimum. Label the vertex on the graph with a big V. V, and state its coordinates. What is the vertex of this parabola? What, comma, what?
0.
The most basic parabola. Most basic parabola goes through 112439. It has a vertex of 0, 0, and an axis of symmetry of x equals 0. And the rest is just moving around from there. The maximum or minimum value of a quadratic function occurs at the vertex, and it's represented by the y-coordinate. Complete the following. Well, you guys stay on this page. I'm going to scroll back. Looking at this particular graph, is the vertex the maximum highest point or the minimum lowest point? Minimum. So in this blank, we're going to say the minimum, I'll abbreviate that with min. I'll abbreviate maximum with max. Value of the function y equals x squared is, and what is the minimum height that it gets to? How high? Also 0, kind of boring right now. But when we start to move around a little bit, it gets a bit more interesting. What about domain and range? Ooh, that's a hazy concept. We're brushing the cobwebs off. Domain tie was how far left and right the graph went. So if the parabola goes like this, how far left will it eventually get? Negative infinity. How far right will it eventually get? Positive infinity. So you can write everything between negative and positive infinity. That's too much writing. Does anybody remember the short version we had for that? Okay, we said all reals, and there was an even shorter way to write that, and we'll be learning that in our first unit. We're going to be learning what's called set notation. X, because it's domain, belongs to a capital C with a peg in the middle, or a curvy capital letter E. All reals. That's the shorthand version. But if you write all reals, I'll figure it out. But I'm going to show you the shorthand because we're going to be emphasizing it in Unit 1. You good, Jordan? Yeah. Good, shut up. Range. Now, range is how high and how low. You are going to have to memorize the difference between domain and range, but I'll be honest, Taylor, ever since I first learned this in Math 11, I always go D, domain, comes before R, X comes before Y, D goes with X, left, right, range goes with Y, up, down. That's how I've done it for years. So the range is how high and how low your graph gets. How high does this parabola get? Infinity. How low? 0. So everything above 0. How would we write that? Well, it's a height, y, height, above, bigger than, 0. Oh, is it touching 0? Is it actually touching 0? Then we show that by saying bigger than, oh, that's a terrible, or equal to. If it wasn't touching, if it was just getting closer and closer and closer and closer and closer, but not touching, I wouldn't put the or equal to. And we'll be talking again more about that when we do a unit later on graphing. This is brushing the cobwebs off. So, in summary, if you compare y equals x squared to y equals a bracket x minus p plus q, the number sitting where the a was told you two things. Whether it opened up or down. It opened up if a was what? Opened down if a was negative. And it also gave you the vertical stretch. We'll talk about how that works. The number sitting where the letter P was what we call a horizontal translation, a slide left-right. And it was backwards in the brackets. So if you had x minus 5, that actually meant the vertex moved 5 right. If you had x plus 5, that actually meant the vertex moved 5 left. The number sitting where the q was gave you a vertical translation, a vertical slide up, down, and it wasn't backwards. So p comma q was the coordinates of the vertex. Oh, and x equals p was the equation of the axis of symmetry. We're going to practice that, and it'll come back to you. And one more thing, every parabola has as its key points. What's the mantra? 1, 1. And I'll show you how we can apply that and really cut down on our thinking to graph these. Next page. Okay. I stole these from various handouts that some of my colleagues who are better with graphics than I am have made. So let's graph a parabola. The first example, which is question number 155, I just yoinked this from some other handout. How do I graph this? We graph the vertex first. So let's do 156 following that step. Graph the vertex first. So it says y equals negative bracket x plus 3 all squared plus 5. Is it a parabola? How do I know? Got a squared, so check. Is it in standard form? Yes. So we can graph this. What's the vertex? What, comma, what? I'm going to zoom in so you guys can see better. What's the vertex of example 156? Of this one here. 3, 5 is wrong. Brackets is backwards. It's negative 3, comma, 5. So let's all of us put a dot at negative 3 over 1, 2, 3, 4, 5 up. There's the vertex. Which way does this parabola open, up or down? I'm just going to make a little note right here in our notes. I'm going to write the word down. In your homework, you don't have to. Just make sure you open it in the correct direction, Logan. Is there a number in front of the brackets that's providing some kind of a stretch? Is there a number sitting where the A is? Everybody say no. No. Then what are our key points? What were they? 1, 1, 2, 4, 3, 9. Look up, watch. From the, which way am I opening, up or down? Yeah. From the vertex, I go 1 over, 1 down, 1 over, I go 1, 1. Then you know what I'm going to go next from the vertex? 2 over, 1, 2, 3, 4 down. 2 over, 1, 2, 3, 4 down. What am I going to do next? 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. 3. By the way, what would come next? 416, I can almost never fit that on the graph, so I don't emphasize it, but if you had a huge piece of graph paper, 416 and 525 would be your next set of counting. And connect them. Coming back to you? Now let's answer the questions. What's the equation of the axis of symmetry? Now the axis of symmetry is this line that runs right down the middle, cutting it in half right here. It's a vertical line, so its equation is x equals what? Negative 3. Can you look at the vertex and tell me, if you know the vertex, can you figure out the equation of the axis of symmetry just from the vertex? Does a negative 3 appear in the vertex anywhere? Can you look at the equation, remembering that brackets are backwards, and can you tell me by looking at the equation without any graph paper, could I ask you to just tell me the equation of the axis of symmetry, and could you do that? I hope. What's the domain? You know what? The domain for every parabola is all reals. You can write all reals, but I'm going to use the shortest way possible. Because every single parabola either goes like this or goes like this. What about the range? Which way does this parabola open, up or down? So it's going to be everything above or everything below. Okay, so it's going to be y less than, below, and touching. Can you look at the vertex, and can you tell me, if I just told you the vertex, could you figure out what the range might be? Well, you'd need to know which way it opened. Oh, but can you look at the equation, and if I only gave you the equation and no graph paper, could you figure out what the range had to be because the equation tells you which way it opens? Y-intercept, I'll read that right from the graph. 0, comma, what? Negative 4? 1, 2, 3, I think 4. I got a dot there right on the y-axis, do I not? Right there, there's the y-intercept. If it doesn't appear on the graph, who remembers how you can find the y-intercept from the equation? To find the y-intercept, make the x 0. So if I went like this in my head, Darian, well, I haven't done that for a while. What's 0 plus 3? Squared. Make it negative. Negative 9 plus 5, and there also is your negative 4, your y-intercept. That was so much fun, Mr. Dueck. Let's keep going. Oh, let's. 157. What kind of a graph is this, and how do I know? What kind of a graph is this, and how do I know? It's a parabola. How do I know? Is it in standard form? Now, you also, did you learn last year that whole completing the square, how to change it from general form to standard form procedure? It's a pain. I'm going to give you stuff in standard form this year, so don't freak out. Okay, it's a parabola. What's the vertex? Positive 1, comma 2. Let's put a dot there. 1 over, 2 up. Which way does this open? Up. I'm going to make a little note there. Up. Is there a number in front of the bracket? Is there an A? Yeah. Put your pencils down and look up. What's our mantra? What number is in front of the A? Sorry, what number is in front of the bracket, sitting where the A is? A half. Multiply this column by a half. 0.5. What's half of 4? What's half of 9? Oh, this graph, you're not going to count 1, 1, 2, 4, 3, 9. You're going to count 1, 0.5 over, 2, 2 over, 3, 4.5 over. Oh, and if you really want to, 4, 8 over if that fits on the graph. I don't know if it will. This is how you can adjust the mantra to whatever value you need. You multiply the y value times the stretch in front. So 1 over, 0.5 up. It'll be hovering in midair, but I'll eyeball it. 2 over 2 up, that I can get exactly. Oh, yeah, if I do it right. 3 over, 1, 2, 3, 1, 2, 3, 4.5, going to be hovering in midair right about there. 1, 2, 3, 1, 2, 3, 4.5. Can I fit 4 over 8 up? Maybe. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Oh, barely. Taylor, that's how I deal with a coefficient in front of the bracket. 1, 1, 2, 4, 3, 9. Multiply the y's by that value. Where you showed that trick last year? It's a good trick. Depends on which teacher you had. Not every teacher knows that. I learned that actually from another good math teacher. What's the mantra, Connor? 1, 1, 2, 4, 3, 9, which I would argue, since you know it's x squared, you can always just derive in your head 1 squared, 2 squared, 3 squared, 4 squared, 5, if you need to keep going. And then if there's nothing in front of the bracket, 1, 1, 2, 4, 3, 9. If there is something in front of the bracket, multiply it on. What's the equation of the axis of symmetry? Well, the axis of symmetry is right there. What's the equation of the axis of symmetry? X equals x equals 1. It's also the x-coordinate of the vertex, and it's also the bracket backwards. Right? Domain, all reals. Range, are we opening up or down? Up. So everything above and touching, and range is y. Everything above and touching, again, can you see where that's hidden in the equation? Hope. Y-intercept, 2.5? 0, 2.5? I'm not going to be that fussy on the y-intercept because often they're going to be yucky decimals and whatever. You know what? 158 and 159 are very similar, but 159 has an... Let's do 159. Let's... What kind of a graph is this? It's a parabola. How do I know? Hang on, we'll take a time out. So I said the vertex was definitely negative... Oh, change colors, Mr. Dueck. Be consistent. Vertex was definitely -1, -3, so I went -1, -3. Which way does this one open, up or down? Which way, up or down? Down, because of the negative in front, so I made a little down note here. And then, well, since I know it's going down, I have room in the top. I went 1, 1, 2, 4, 3, 9, and I'm going to multiply this by... What's in front of the bracket? 1/3. 1 times 1/3 is 1/3. Ugh. 4 times 1/3 is 4/3. Yuck. Ah, but 9 times 1/3, what's 1/3 of 9? You know what? I'm going to get 3 points on this parabola. It's going to be the vertex, check, and it's going to be 3, 3. And I'm just going to eyeball the rest and say it looks kind of like that. So when I have done the parabola over the years, I've always been insistent, kids find me the vertex, at least 2 other points. Sometimes you can get more. But from that key point mantra method, you can always find 2 plus the vertex. Is that okay so far? Axis of symmetry. X equals -1. Domain, all reals. Range, everything above or everything below? Less than or touching. Range is Y. And, everything below -3. Y-intercept, this is a yucky decimal. I'm going to say, forget it. Okay. One more, and I'm going to turn you loose. Let's do number, how many got that okay? Okay. Number 160. Is it a parabola? Check. By the way, the reason I always say that is when I first introduce the parabola to grade 11s, they get parabola happy. I'll give them this, y equals 2x plus 3, and they'll start graphing a parabola because, no, there's no squared. That's a line. That's slope-intercept form, so don't get parabola loopy here. Vertex, what comma what? 2 comma -2. Boom. Oh, right on the bottom here. Opens which way? Okay. 1, 1, 2, 4, 3, 9. What's my mantra? 1, 1, 2, 4, 3, 9. Is there something in front of the bracket? There is. So each of these is going to get multiplied by what's in front of the bracket. It's going to be 1, 2, 2, 8, 3, 18. I doubt the 318 is going to fit on the graph. Might, but I'm pretty sure the 1, 2, and the 2, 8 can. 1 over 2 up. 2 over 1, 2, 3, 4, 5, 6, 7, 8 up. I don't think the 18 is not going to fit. By the way, compare these 2 graphs. Do you notice it turns out a fraction in front of the bracket makes it fatter. A whole number in front of the bracket makes it thinner. It would be wonderful if there was an easy way to remember that fractions make it fatter. It would be very convenient, Mr. Dueck, if you could give me some dumb easy way that I can remember that fractions make it fatter. If I was a good teacher, I'm sure I'd come up with something, but I got nothing. You know what's amazing is there's still a few people, I don't get, huh? Oh, well, do the best you can. You know what? I'm going to try filling in all of the information below only from the equation without the graph. Axis of symmetry comes from that right there. X equals -2. Domain, all reals. Range, it opens up, so it's going to be everything above and touching. Why?
Isn't the axis of symmetry +2?
Of course it is +2. Jeez. Frussin can't. Thank you for fixing that error. Y greater than or touching, above or touching, -2. Coming back to you, okay? So what's your homework? Lots of practice with this. So on the following pages, sketch those. Okay? And then, I think am I just having you sketch a bunch? And then on here, can you tell me the answers without actually graphing? And I've tried to include the answers here of the sketches and stuff. So the only worry is I made up the answers for numbers 185 to 188, so there could be just saw, because I do make mistakes all the time. But I want